we can represent a relation in many ways. One way being a table. So if we have this table and we're given the ordered pairs here, 1, 3, -2, 0, 4, 2, and -3, -4, then we can just transfer our x values, which are 1, -2, 4, and -3, right to our x column. And then we transfer our y values, which are 3, 0, 2, and -4, right down to our x column. And it would look something like this. That's one way to represent a relation. And that's telling us that when x is 1, y is 3. When x is -2, y is 0. When x is 4, y is 2. When x is -3, y is -4. It's showing us how our inputs relate to our outputs, how our x value relates to our y value. Second way we can represent a relation is by using a graph. We can do that very easily. Here we would plot our ordered pairs listed above, and we are given this graph, which shows our relation. Third way, we can use mapping. That is very literally mapping out which input and output belong together. We're using arrows, and we're saying, okay, 1, this x value, or this input, belongs to 3, this y value, or this output. And we're mapping it out using an arrow, connecting an input to a given output. When we're mapping, we typically see our x values or our inputs circled or somehow distinguished from our outputs and then mapped using arrows or lines. Domain and range. Think of domain as your x value. Think of range as your y value. Regardless of how your relation is represented, whether it's on a graph or in a table or ordered pairs or mapping, our domain is our x value, our range is our y value. When we're asked to give domain, we're listing a set of all x values. We can think of domain as our input. It's the x coordinate, the x value of the point, and that's our input value. It's our independent variable. It does not depend on any other variable. It's independent. It can be assigned any permissible value. Range is the set of all y values. It's thought of as our output. So when we plug in a given x value, our input, we are going to get out a given y value or output. And since our y value depends on which value we're assigning to x, we call it our dependent variable because it's dependent, its value is dependent on our x value or our input. Again, domain, the set of all x values, range, the set of all y values. Let's look at that. If we're talking about a table, our domain would be the set of all x values, domain. Range, our set of y values. If we look at an equation, we have x, which is our input or our independent variable, y, which is our output or dependent variable. To make dependent and independent variables make more sense, if we assign the value 2 to our x, then we'd have 2 times 2 plus 1. We would just plug in 2 for that x value. And our y value, our output, depends entirely on what the value of x is. Because if x is 2, well, then y is 4 plus 1, which is 5. But if I assign a different value to x, I'm going to get a different output. So our y value, our output, our dependent variable depends on the value of x. Finally, we can look at domain and range on a graph. Domain, we said, is the set of all x values, so it's going to relate to our x-axis. Range is our set of all y values, so it's going to relate to our y-axis. As you go further along in math, you're going to think of domain as how far, how wide, or how far you can go right or left, and range as how far we're going up or down on our coordinate plane. Finding domain and range. Okay, we said domain is the set of all x values. So what are my x values? I have 2, 5, 7, 8. And I know these are my x values because I know that ordered pairs are always written in the form x, comma, y. So that first number in my ordered pair is going to be my x value. If we put those together and create a set of x values, we get 2, 5, 7, 8, just like this. Our range, we said, is our y value, the set of all y values. So here we would get 5, 11, 15, 17. Number 2, our domain is the set of all x values. Again, we know x is -2, -1, 0, 1. And that's what I see right here. And then my range is the set of all y values. My y values being -1, -3, -5, -7. And there we go. Now, what if I have a table? I actually think looking at a table is easier when determining domain or range because domain, we said, is our x set of all x values. And look at that. We have the entire set right here. So here our domain is 5, 6, 7, 8, 9. Our range is our set of all y values. Here are our y values, 1, 2, 3, 4, 5. Simple as that.